You were given some intuition about the doubly linked list and also doubly linked node in the chain. Let's now see how we can implement the doubly linked list using generic classes in Java. And the implementation will be very similar in terms of declaration for the generic class and also attributes as in the case for simply linked list. But I'll show you explicitly the extension that you want to watch out for, and then we'll do some tracing of some example JUnit test. That's what we'll do. Right, let's now talk about the doubly linked node. In the name, I simply just call it node again. I didn't really call it doubly linked node, but in your personal project, maybe outside the scope for the course, you can feel free to call that maybe doubly linked node. That'll be okay, right? And all the source code is also available to you. Let me show to you very quickly. If you simply import the project's example generic linked lists, which were made available to you last week. So if you open the projects, you can see under generic DLL, doubly linked list. This is where you can look for. You will see the node and also doubly linked list, which I'm going to go over with you quickly on the slides. And now visualize how to do the tracing for initializing empty list. Right, so this part here is exactly the same as doubly linked node. You got elements and also you got next. And also you got the mutator and accessor for these two attributes. And the one new attribute we introduced for the doubly linked node will be the previous reference over here, right? You can see the previous over here is a reference to some node. And since we talk about generic class, so that's why you have to also say E over here, right? So we spoke about how you can use Java generics both in the background study and also in the examples that we did last week. You want to make sure you actually understand that. That'll be required. Right, and also we got a public accessor for this private attribute previous, get previous. And also we can set a previous as well, right? You can see the node over here is also generic. Meaning that, for example, if I instantiate this E over here to be a string, in that case, this E, and also this E over here, for example, they will be instantiated to be string accordingly. Right, and for the constructor, you can see we got elements and also the next node as before, but now we also introduce the previous node and we simply assign that to the previous attributes accordingly, right? Everything is kind of conceivable, very straightforward. You just have to watch out for what's really the extension we are introducing here. That's about at the node level for each individual doubly linked node in the chain. Let's take a look at what the doubly linked list class will look like. So doubly linked list itself is also generic. Right, we got all these, we got the attributes over here, size, but we don't have head, we don't have tail. Remember, we got header and we got trailer. We'll see them. And also we got the basic methods, for example, like here. And we got header and also we got trailer. Each one of them will be a dedicated node, right, which is also generic over here. And also we got the constructor over here for doubly linked list, which will simply initialize an empty list. And if you recall what we did earlier about the empty case, right? Eventually we should really construct something like this for the empty doubly linked list, right? That's what we said earlier. You can definitely review it if you got any doubts. Right, what we're gonna go over will be, we want to take a look at when you actually call this particular constructor, what exactly is really happening, right? And notice that these 3 lines of code would be equivalent to if you actually try to simply create a header and trailer, just make everything to be null to begin with. And then you're going to set the next and previous accordingly afterwards, right? As opposed to here, you can see when we try to do the trailer, since we already got a header reference, we can simply put header over here, just saving one line, right? So either you can put a header over here, or you can put null over here, and you need an extra line. Either way works, right? I'll leave that comparison to you, but they are equivalent to each other. Let me now try to trace the code together with you. It's a very simple test case over here, right? We simply want to test for the case where E generic parameter is instantiated by string. We want to see how we can create an empty string list accordingly. Let's see. And let me just mention to you very quickly once more about the extension. So at the node level, over here, we actually got the previous reference and also the associated accessor and mutator methods for the previous reference. And in the doubly linked list level, we actually got the header and also the trailer, right? So these are the two. So these are the exact extensions that we introduced in the case of doubly linked list. Let's now see how we can trace this fragment of code. Namely, we are basically calling doubly-linked list over here, and we want to create an empty one, call it list over here, and we're instantiating every element there to be a string. As we illustrated before, now once you have done this decoration, every occurrence of E, we're basically instantiating the E over here in the doubly-linked list by string. And accordingly, every occurrence of E, including, for example, the E over here, E over here, E over here, and etc., they should be instantiated by string accordingly. And also, since the header and trailer are referring to the node class, so this E is going to be replaced by string. Accordingly, the node of E, the E here, is also replaced by string. And every E, accordingly over here, E and E and E here, will also be instantiated by string, right? You can see it's really cascading effects that we are doing here. Just make sure you understand. That's something we covered already in the previous part of the lecture. And let's now see how we can trace the constructor over here to construct the empty doubly-linked list. So we're calling the constructor for doubly-linked list, which will be over here. And then we're simply creating the header and trailer. So we got header here, and also we got trailer over here, right? So here I'm showing to you this particular version over here. It would be your exercise. Let me show you it again. I'm going to trace to you for this particular version. You can try to see how this particular version over here, the second version, would, why it would be equivalent to the one I'm going to trace right now, right? I'll leave that as an exercise for you. Okay. And how do we trace this? Right, already got some template over here for the node, right? That's something we spoke about in the intuitive introduction. So let's execute line by line. The first line will be the header, in which case we're going to call the constructor for the node class. So we need a new node objects, right? So let me just copy this, and then let me put it in the middle over here, right? So this one will be the header, and let me just make it green, just to be consistent with the color. So let me put green over here. Right, so this one here is the header. And what about its attributes? You can see we got null, null, and null. Corresponding to the element E should be null, and also the previous node should be null, and also the next node should be null, right? Null, null, null. So all of them should be set to null in the beginning. Let me use maybe just orange over here. Right, so that means the element is actually going to be pointing to null, and the next node is also going to be null. Of course, we're going to set it to be the trailer a little bit later, and also the previous node will also be null. Right, so that's the complete tracing for this particular constructor call for the node class. Right, let's do something similar. And what about the trailer? When we execute the second line over here, and let me just paste another node object over here. Let me also make it green, just to say it's a special node. Right, so this will be trailer over here. Okay, the trailer. And now notice that we for the element it will still be null. However, for the previous node it's going to be header, and for the next node it's going to be null. Right? So be careful about here. You can see the null over here means that we're going to replace this E by null. That's how you can think of it. And the header over here, call by value. So the previous node over here is actually going to point to wherever the header is pointing to, right? You can think about call by value. The P is really pointing to wherever the header is pointing to, right? And when we say the previous is really assigned to P, so that means the previous is now going to point to wherever P is pointing to, right? That's kind of the aliasing that you should be familiar with already. So what I will do is, you can see the previous is going to point to wherever P is pointing to, right? So this is how the previous node for the trailer has been set up. And also we're going to, for the elements, of course, we said it should be null. And what about the next node? The next node is also going to be null over here, right? Right, the next node is also going to be null. Right? Let me just write a trailer a little better. All right, and we got a final line to really execute. And since we haven't really established that header.next is actually pointing to trailer, right? That's according to our intuitive introduction. And that's exactly what this line will do. So header.setNext trailer. So what we're doing is we're calling the setNext method, which is over here, right? setNext. You will simply say this.next is assigned to n, and the n over here should be pointing to exactly where trailer is pointing to, call by value again. So n is really pointing to wherever the trailer is pointing to over here, and then we are saying that the next is assigned to n. Which one's next? It should be the context object, which will be header.next. So header.next is going to point to wherever n is pointing to. So that's why it's pointing to here. Right? I'm going a little bit fast over here because I'm assuming that you actually are familiar with the call by value that we spoke about earlier, also what you learned in 2030. Right? Right, so what we'll do is the next, rather than pointing to over here, is now going to point to over here. Right? So that's the setup over here. So after this, for the empty list, you can definitely try to call out a method to make sure the size will be 0, because there's no meaningful nodes storing some data in between. So that's why the size should be 0. And when we say get first and get last, so these are simply just to get the first node that's in the list. Well, let's say let's go back here. If you got this non-empty list, the first node will be this node here. The last node will be this node over here. You can look at the implementation about how these are implemented. Well, let me show to you very quickly. But I will leave the implementation detail to you. If you go to the Doubly-Linked list over here, right, if you go to get first and get last over here, right, you can see in the case where size is equal to 0, in that case, we don't have any nodes storing meaningful data. So that's why it should be null. In the case where the size is not equal to 0, that means we got at least one node in the list, in which case it will be just header.getNext, right? That's according to our intuitive introduction. And also symmetrically for getLast. In the case where the list is not empty, in that case, the last node will just be trailer.getPrevious. What about second last node? Trailer.getPrevious.getPrevious, right? Everything makes sense. Okay, like that. And in addition to the JUnit test, I would like to show you very quick Boolean expression that should be evaluated true as well in the case of the empty list. Let me write it down over here. So now if you try header dot get next, of course, equals trailer. And also if you try trailer dot get previous, that will be exactly equal to header, right? So these two assertions will be true in case you the list you have constructed is simply just empty, right? So these two will both be true, right? Just to summarize about the diagram that we have constructed over here. Okay, so that's about the Java implementation for the two classes. You should definitely make sure you understand exactly what the extensions are at the node level, and also at the Doubly-Linked level. And also know about whenever you construct a node in the list, you have to make sure you worry about 3 attribute fields: the elements, the next, and also the previous. And starting from the next video, we'll actually start talking about the different methods in the Doubly-Linked list and how we should implement them using the extension.